This is my EngPhys 2PO4 design project. My problem is essentially a square Allen key, which can be shown here, with its x equals 0 surface fixed and a force applied in the center of the end of this y extension on that face. This screwdriver has dimensions specified above, and it's made of steel, so it has a Young's modulus of 210 GPa gigapascals and a new Poisson's ratio of 0.3. So my goal for this project was to calculate the moment that the applied force produces on the square cross-section of the x equals 50 millimeter face, the shear stress distribution caused by this twisting moment on the x face, and the angle that the centroid at the end of the x extension twists through, as well as the z displacement of this face, this y equals 120 millimeter face, using both Maple and FlexPDE. Okay, so I first calculated the moment by crossing the force, which was 100 newtons applied on the end of this face, with the total distance from the end of this y extension to the middle of this x extension over here. So that turned out to be 100 newtons times 116 millimeters, which is the distance from the edge of this face to the end of the y extension, plus 4/2 millimeters, which is half of the cross-sectional length. So it's right in the middle there, and that gave us 11.8 Newton meters, and the resultant vector will be pointing in the negative x direction, which means it will cause a clockwise rotation of this face around the x-axis, kind of in this direction. And the reason this vector is negative is because if you cross the length of this extension times the force, it gives you a vector in the negative x direction. Okay, so to find the stress distribution that produces the moment calculated above, I took the moment calculated above and divided it by the integral of the distance from the centroid on the x surface squared, and that's the integral of the area. So in both z and y, from z equals 0 to the cross-sectional length, and z equals 0 to the cross-sectional length. So I did that for both on both surfaces in both directions that I needed to consider, and then it gave me this calculation down here. So this shows that the stress on the x surface in the y direction increases in the negative z direction, and also that the stress on the x surface in the z direction increases in the positive y direction. And since the distance to the applied force decreases when moving in the positive y and negative z directions from the centroid, it makes sense that the stress would increase because it's closer to the applied force. Okay, then I found the angle that the centroid twists through at the end of the x extension by multiplying the distance from the x equals 0 face to the center of the x extension at x equals 48 millimeters. Multiply that by the moment calculated above, divide that by the torsion constant, which, since this has a square cross-sectional area, it's 2.25 times the cross-sectional length to the 4, and then g is just the shear modulus, which we calculated before, and then this gave me an angle of this. However, in FlexPDE, it was ultimately reported as different. I also calculated the z displacement of the end of the y extension due to shear by multiplying. This is kind of like taking the strain, multiplying it by the length, and then adding the angle times the length in y. And then this would give me the displacement due to shear. However, I had differing calculations in both Maple and FlexPDE, which I have explained why I believe this is the case in the reflection. So throughout this course, we've learned about different types of deformations that must be considered in analyzing and designing structures. These types of deformations are due to normal forces, shear, flexion, and torsion. So now that I have an understanding of all these kinds of deformations, I can analyze and design systems with a deeper understanding of how they work and how they might fail under certain situations. Torsion was the most relevant deformation to consider in this problem because the applied force produced a moment which caused a torsional deformation in the x extension.